Assalamualaikum warahmatullahi wabarakatuh and good day everyone. My name is Sharuniza bin Mokata. Currently, I am attached with Department of Structures and Material Engineering, Faculty of Civil and Environmental Engineering, University Tun Hussein of Malaysia. Today, I would like to present our investigation on Johor Bahru Waterfront Lot 1. So this building is located at number 1, Persiaran Tun Seri Lanang, Jalan Skudai, Johor Bahru, that face the sea, the Brow Straits, as shown in figure 1. The original 10-hectare Johor Bahru Waterfront City project that was scrapped in August 2003 will now be redeveloped into a tourist, commercial and recreational spot. The objective of this investigation is to observe the mode of defect and deterioration as well as to determine the causes of the concrete structures problem of the building. Visual examination approach had been used as a tool in assessing the type of concrete deteriorations. Initially, through this observation, the degree of deterioration of rear or back part of this building is more severe than the front area. It may cause from the seawater chloride penetration or due to the surrounding environment. There are many types of concrete problems that had been identified during this investigation. Statistically, those problems can be categorized according to its classes based on its basic mechanism of failure and nature of problems. Through the survey that had been conducted, typical problems were as of the following list. Number 1 is cracking, number 2 is tanning due to the agar growth, and number 3 is spalling that can cause delamination, and finally number 4 is corrosion of the concrete. Cracking can occur due to differential, load-independent, dimensional changes due to the heat of hydration and moisture loss, and can be caused to the alternative wetting and drying and cyclic variation in temperature. Load-dependent dimensional changes can also cause cracking quality of structural concrete with less or lost its ability to resist deteriorations. Visual examination for the micro cracking shows map and pattern of the cracking. So this visible crack appeared typically at wall surface as shown in figure 3. This initial stage of cracking may contribute to the major cracking as shown in figure 4. Microcracking will give carbonate, sulfate and chloride ion for coming in and penetrate slowly into concrete until reinforcement steel start to corrode. In figure 4, shear cracking appeared at the corner of the wall while long cracking pattern occurred on beam as shown in figure 5. The width of the both crack approximately at least from 10 to 20 mm wide. If no immediate repairing action to be done, sooner or later, the reinforcement will start to corrode tremendously. Crack appeared on edge of column may occur due to insufficient of reinforcement that cause overstress of the reinforcing steel. In figure 6, as we can see, crack occurred vertically for 4 meter height length along the main column. Shrinkage is caused by the loss of moisture from concrete. It may be divided into two general categories, that which occurs before setting or plastic shrinkage and that which occur after setting or drying shrinkage. Cracking caused by plastic shrinkage will be seen within a few hours of concrete placement. Typically, the cracks are isolated rather than patterned, so these cracks are generally wide and shallow. Cracking pattern due to shrinkage can be observed in figure 7. Basically, for most common location of this deterioration can be determined on pavement slab. However, this type of cracking can also occur on wall due to the loss of moisture for long-term change in volume of concrete. Growth of concrete structure may lead to mechanical deterioration caused by lichen, moss, alga, and roots of plants and trees penetrating into the concrete at crack and weak spots. By looking at figure 8 at a glance, one simple visual examination might be concluded, as the agar or other growths come into the concrete due to the cracking gap. So this might be due to the high water-cement ratio that lead to higher permeability and eventually increase its porosity. Furthermore, microgrowths may cause chemical attacks by developing humic acid, which might dissolve the cement paste. Staining appeared typically at main beam as shown in figure 9. The width of the crack approximately ranging from 1 mm to 2 mm wide. Staining might be occurred when water penetrated through the gap of the cracks. This also can contribute to the growth on the concrete structures. Spalling and delamination occurs due to expansion of reinforcing steel due to the corrosion. When chloride penetrates to reinforcing steel, corrosion begins, and spalling delamination will also occur as shown in figure 10. Penetration of the chloride starts at the surface and then move inward. Eventually, the concentration of chloride in contact with the reinforcing steel will cause corrosion when moisture and oxygen are present. So as the rust layer builds, tensile forces generated by expansion of the oxide cause the concrete to spall and delaminate, as figure 10. If no action taken by the authority, it may cause the major structural problem afterward. Visual examination will typically reveal rust staining of the concrete. This staining will be followed by cracking. So crack produced by corrosion generally run in straight, parallel line at uniform intervals corresponding to the spacing of the reinforcement. As deterioration continues, spalling of the concrete over reinforcing steel will occur, with the reinforcing bar becoming visible. However, in figure 12 shows the spalling of the concrete can give the diffusion of carbon dioxide come into air-filled pores. Chloride can be introduced into concrete by coming into contact with environment containing chloride, such as seawater. Penetration of the chloride starts at the surface, then move inward. So figure 13 shows the initial stage of the chloride attack on beam at sea area. Therefore, it would be simplistic to suggest that it will be possible to identify a specific single cause of deterioration for every symptom detected during an evaluation of a structure. Based on the investigation, we might say that the cause of the deterioration of concrete as listed: number 1 is the accidental loading, number 2 is chemical reaction, number 3 is construction error, number 4 is corrosion, number 5 is design errors, number 6 is erosion, number 7 is freezing and thawing, number 8 settlement and movement, number 9 is shrinkage, number 10 is temperature changes. As a conclusion, we found that Johor Bahru Waterfront Lot 1 has so many concrete defects on their building. However, this investigation only investigated the external area because this building has been scrapped and no longer operations since 2003. By our visual inspection, we found that the major defect on their concrete structure is cracking and followed by spalling, staining, and the corrosion of the concrete. These symptoms can be related to some possibly causes such as biological and physical attack and surrounding environment. Thank you very much.